So our lessons that we've been working on from 7.1 to 7.3 have been involved with us getting some comfort in working with polynomials. So in section 7.1 we learned first and foremost what a polynomial is, then we learned how to add and subtract polynomial expressions. In section 7.2 we worked on just multiplying polynomial expressions, and then in our last lesson we learned about special products of binomials and special patterns that we had to use. Our new lesson shifts from doing operations with polynomial expressions, and it kind of moves towards solving equations, and it really seems like we're getting away from polynomials, but the product or the zero product property that we're going to learn here is used extensively whenever you have equations that have polynomials in them and you need to solve for the variable. The normal tactics you use for solving equations that are linear, so an equation like 2x plus 5 is equal to, I don't know, 72, something like this. The way you solve this to get the value of x is you undo everything that's happening to x. You use inverses. You get x by itself. You subtract 7 from both sides to get 2x is equal to 67, and then you divide both sides by 2. What we're doing, this action of subtracting 5 from both sides, this action of dividing 2 from both sides, it gets x by itself, and that's how we ultimately get our answer for what x is. Here it's 33.5 for what we get for x. So with polynomial expressions, or polynomials expressions within equations, if you have something like x squared plus x minus 6 equals 0, you can't get x by itself. There's nothing you can do to both sides to end up stripping away what's happening to x and ultimately get x equals something from performing operations to both sides. It's not possible in this equation. So there has to be another way in order to solve that type of equation. And what it is zero product property. So this lesson is kind of a transition into what's going to be used in the upcoming sections, which is something called factoring. But we have to understand how to solve equations in factored form, and then we'll get into the business of how do you factor. So this is not a terribly horrible property you're going to be learning here. It's rather basic, and it all starts with the zero product property. So if we're told a times b is equal to 0, what we know, if we have two factors involved in multiplication and the product is to be 0, what we know is if this factor is 0, we have a solution. Think about it. It doesn't matter what b is. If a is 0, 0 times anything is 0, right? Likewise, if b is 0, it doesn't matter what a is, because a times 0 is 0. So if b is 0, we have a solution. If a is 0, we have a solution. That's pretty much it. That's what the zero product property is. It also has the added part where it says, and both a and b can be equal to 0. It's possible 0 times 0 equals 0. So it can happen when one is 0 or the other is 0, or when both are 0. But how does this look when we have to solve an equation and we have to employ the zero product property? Well, what you'll see is an equation in what's called factored form. So you will see expressions involved in multiplication. You might see something like 2 times x plus 8 equals 0. And this is basically the zero product property, but the a is kind of hidden and the b is kind of hidden. Look, 2 times x plus a. The 2 is a factor. That would be almost like if we saw a times b times c equals 0. 3 factors multiplied to be 0. Here we have 1, 2, 3 factors being multiplied to be 0. We can find a solution if any of the factors can be made to be equal to 0. Well, this factor is 2. What makes 2 be 0? Nothing. 2 is 2. 2 doesn't change. 2 is something called a constant. So this constant value, which is a factor, that doesn't give us any solutions. Well, this x is a factor. We can ask ourselves, what makes x be 0? Well, we just gave it right there. What makes x be 0 is when x is 0. So look here, if x is 0, you end up with 2 times 0 times, if we put 0 in, we'll get 0 plus 8, which is 8. 2 times 0 is 0, 0 times 8 is 0. So if x is 0, this is solved because 0 equals 0. So this is one of our solutions. So there's nothing that makes the 2 be 0. When x is 0, x is 0. We have to now figure out what makes this whole factor be 0. So what makes x plus 8 equal to 0? Well, hopefully you remember if you add opposites, you get 0. So x equals negative 8. If x is negative 8, negative 8 plus 8 is 0. So this is a solution. Look, if we let x be negative 8, we will get 2 times negative 8 times negative 8 plus 8, which is what? 0. 2 times negative 8 is negative 16. Negative 16 times 0 is 0, and 0 equals 0. So we get this solution 2. So these are the two solutions to this equation. In fact, I think it's easier to solve equations using the zero product property, because all you have to do is figure out what makes a factor be 0. And very often our factors will look like that, and there's not much we have to do to figure out what makes them be 0. But this only works, zero product property only works when we see our expression in factored form. So real quick, here's another example. I'm going to give you one that's in factored form again. So if we saw something like x plus 3 times 2x minus 1 equals 0. This is a factored form because we have an expression times an expression equal to 0. Again, this one would be acting like your a, this factor would be acting like your b, and it's basically saying a times b equals 0. So we want to figure out what makes x plus 3 be 0. What makes x plus 3 equal 0? We also want to figure out what makes 2x minus 1 be 0. And what do you add to 3 to get 0? You add negative 3. Negative 3 plus 3 is 0. So negative 3 is a solution because look, if we put negative 3 in, negative 3 plus 3 is 0. If we put negative 3 in here, it doesn't matter what that is because 0 times anything is 0. So that's one of the solutions. What makes 2x minus 1 be 0? Okay, now we have to solve. Add 1 to both sides, you'll get 2x equals 1. Divide both sides by 2, you'll get x equals 1/2. This is also a solution. Because look, if we put 1/2 in here, 1/2 times 2 is 1, 1 minus 1 is 0. If we put the 1/2 in here, it doesn't matter what this is because anything times 0 is 0. There's our two solutions. That's what it looks like when you're given a factored form for a polynomial and you're trying to solve the equation. If you have one in unfactored form, something like x squared plus 7x is equal to 0, and you have to solve this. These aren't factors now. They're not factors because they're separated by addition. So we have to put it in factored form by factoring this polynomial. Now, that's a two-term polynomial. I hope you remember that you have learned how to factor these by factoring out the common factor between both terms. This term x squared and this term 7x both have a factor of x, so we can factor that x out. When we factor that x out, what's left? Take an x away from an x squared, you're left with an x. Take an x away from a positive 7x, you're left with a plus 7 is equal to 0. Now it's in a factored form. Something times something equals 0. What makes this factor be 0 is 0. What makes this factor x plus 7 be 0? I think you can see it's negative 7. There are your two solutions. And it only worked when it's in factored form. Factoring, the factoring that we're going to be doing in this lesson is the type of factoring you saw here, where you're undistributing a common factor between all the terms. In the later sections, we'll be learning other types of factoring that we can use to solve equations that have polynomials.